That's an equation of a circle. What's the radius of this circle?
5.
It's 5. It's 5. Or squared 5. Okay. So let's say we have a point here, 3, 4. Is that on that circle?
Yeah, because you know the circle.
Yeah, we always test. It could be slight. Just because I drew it on doesn't mean it's on the circle.
But then why would you lie to us?
I'm testing you.
It's not that.
3 squared, 4 squared is 25. Yes, it's on the circle. Fantastic. What's the gradient of the tangent at that point? So we expect it to be downhill, don't we? This is a bit awkward, the way this is written. So I'd have to get y equals to derive, wouldn't I? So let's do that. Y squared is 25 minus x squared, yeah? Y is going to be plus or minus the square root of 25 minus x squared. Does that work as a function? Plus, minus? Does that make sense?
It's a negative gradient.
Hmm?
Does that work? I don't know.
Well, because a circle isn't a function, it's what's a relation. Very good. It doesn't pass the vertical line test, does it? No. But if you separate it into 2 bits, the plus bit being this part of the circle, the upper hemisphere, and the minus bit being, so the minus function is this bit, and the plus function is this bit. We can think of it as 2 functions, kind of. So which function do we want to deal with, the plus one or the minus one for our point? Plus. Okay, so that makes it easier. We'll just deal with the plus function because we know it's on the plus side. So we have this function. We're just going 25. All right. We have to derive this, which we're able to do. We can do a little rewrite if we want. X squared to the power of a half, isn't it? Not negative half, just a half. Derivative is 1/2, using my favorite chain rule. And then multiply by what?
2x.
Derivative of the inside, negative 2x, very good. And we tidy that up a little bit. 2's might cancel here today. Yeah, so negative x over the square root of 25 minus x squared. Now I want to find the gradient at that point. What would the gradient be? Sub in 3, yeah. So I have negative 3 all over root 25 minus 3 squared, which is root 16, isn't it? Oh, it's negative 3/4. Okay, so the gradient there is negative 3/4. That makes sense as a gradient there. This feels like maybe a complicated process. What happens if I cannot separate the x's and y's? Like I was able to separate them here. What happens if I have something like x squared plus xy plus y cubed is equal to 100 or something like that? How do I separate how do I get the y's on this side and the x's on that side? That's a good question, yeah.
Can't you, factor x out?
No, he's not everywhere.
Yeah,
It's a problem, yeah? So I can't just let it y equal and then pick which bit of the function. This is also a relation, so I couldn't pick which bit because I can't separate it. So it's a bit tricky. So in these circumstances, I got to use something called implicit differentiation. So what does that mean? Well, we kind of just derive it as it is. So let's go back to our original function, or relation, not function. Be careful. Let's just derive this on the spot. So x squared plus y squared equals 25. I'm just going to derive each thing with respect to x on the spot. So I'm going to, this is the terminology for saying that. Derive with respect to x. Derive with respect to x. What we've been just doing, deriving with respect to x. This pen's not good either.
Wait, what is this for?
We're just, if we can't separate, so we could separate this and get y equals and then derive it. But what happens if we can't separate? That's where implicit differentiation comes in. Now, 2 of these terms, we're going to go easy. What's the derivative of x squared?
2x.
Very good. What's the derivative of 25? Nothing. What's the derivative of y squared? Close. So we're deriving it with respect to x, but it's y squared. This is good thinking. What is y? What is y normally when we write y? What is it?
X plus C.
It's a function, yeah. It's a function. So y is a function. So let's say we'd sum function squared. Think of a function squared. Okay, let's just put in a random function squared. What's the derivative of any random function squared? We'd have to use what rule? Chain rule. So we would, yeah, you could expand the brackets here, but let's say it's a more difficult one. We don't know what the function is, but in general, we could always use chain rule for a function squared. It's twice the function times the derivative of the function times 2x, yes? So if the function was just y squared, it'd be twice the function multiplied by what? The derivative of the function. What's the derivative of y? dy dx. The derivative of y is dy over dx with respect to x. Okay, this is what we sub in here. This is the derivative of y squared. It is 2y times the derivative of whatever y was, whatever function y was. Right. Now what we need to do is rearrange so we get the function dy dx is the subject of the function. Now we can separate. At the derivative stage, we can go 2y dy dx equals negative 2x. So the derivative is negative 2x over 2y. Do you see that? We divide down by the 2y. Now what is the gradient at 3, 4? Now this time we have to sub in 3 and 4 because we have x and y. So the derivative is minus 2 times 3. Do we see this? All over 2 times 4, which gives what gradient? Negative 3 over 4 still, which is what we got here. Now, the interesting thing, or maybe not, is that we can do something like this much easier now, or we can do it now. We can get the derivative, we can get the gradient at particular points along it, but it'll be in terms of x and y. So we need both the x and the y point to get the actual gradient. And we don't need to separate it into y equals because we can't. So let's look at a couple of examples that I have going to do, and then you can do it. So each time you're going to just use the chain rule. Where's we? Here. Each time we're going to use the chain rule. So if you want to try these before me, you can. Maybe I'll just do the second one and the last one. So the first one is very similar to what I did. So I'm going to do this second one here. X squared plus x squared y plus y cubed. Oh, it's very similar to the example I have up here. Anyway, all right, we have something like this. This cannot be separated. We can't get y equals.
X.
It's x.
But, yeah, there's no square on that.
Oh, yeah, okay. Thank you. All right, let's try and find the derivative of this by getting the derivative of each individual term. Now, you don't need to write d dx.
What does ddx mean?
The derivative with respect to x.
Find the difference between that and dy dx is d?
That is the change in y over the change in x, which is a very similar thing. Okay. What is the derivative of x? With 1. Fantastic. Easy. What's the derivative of x squared y?
dy over dx. Oh, 2 dy.
So these are two functions multiplied by each other, x squared and y. So what rule do we use? Product rule. So I'm going to use the product rule. The first by the derivative of the second, plus the second by, there's two functions here. X squared is one function, y is the other function. So the first by the derivative of the second is x squared multiplied by the derivative of the second, which is, what's the derivative of y?
dy.
1 dy dx. So it's just dy dx. Plus the second by the derivative of the first. So that's Are you happy with 2xy?
Yeah.
Mildly, maybe. So the derivative of this is 2x and just times the y. What is the derivative of y cubed? Similar to this one. So it's like chain. 3y squared will be the outside part of the chain rule. And then the derivative of y afterwards is dy dx. Equals, what's the derivative of 100? Sorry, I didn't write in the 0. Yeah. Okay. You could just go straight to this line. You don't need to write that. What do we do next? Yeah, we got to isolate dy dx. We want the derivative function, so anything that's not dy dx, bring it over to the right. Anything that is dy dx, leave it on the left. So let's start off with that. I have x squared dy dx plus 3y squared dy dx is equal to, and minus 1 minus 2xy. Just this fella and this fella has gone over there. Subtract it from both sides. All right.
Factorize it now.
Very good. I'd factorize out. Yeah. I've factored it out. I presume you recognize that I can just divide down by that then. Is that okay? 1 minus 2xy divided by x squared plus 3y squared. And that's the derivative. Okay, I don't need to do that. That is implicit derivatives.
That's
Hmm?
it?
That's fine. Once you have the gradient function, there's no point to sub in this time. In the second example there is. I don't think I need to do the second example. Maybe I will just to, it's the same. So I have x squared plus y squared equal to, cubed, is equal to 5, it says, I think. At the point, so find the gradient at point where x is equal to 3. Okay, so I'm going to go straight into finding the gradient function. I'm not going to write dx, ddx. I'm just going to go straight into it. I'm going to say 2x plus, help me out with this one.
3y squared dy dx.
Very good. So chain rule. So the derivative is this. It's equal to 0. Isolate the dy dx. I think it'll be 2 minus 2x divided by 3y squared. Very good. Now, this, at x equal to 3, where's the problem?
Yeah, we don't have the y.
How do we get the y?
Put it into the original.
Yes. So we can get a y value by using the original function. 3 squared plus y cubed is equal to 5. That's going to be y cubed is 5.
X equals 2.
X is 2, not 3.
Oh, is it? Oh,
Yeah.
sweet. That makes it much easier. That's 1 then. Y is 1. Is it plus or minus?
No, because
No.
it's an odd.
Yeah, it's odd power. Yeah. Okay, so y is 1. Now I can get the gradient. Minus 2 times 2. X was 2, not 3. And 3 times 1 squared. So the gradient at that particular point is minus 4 over 3. All right, so you have your choice now. I'm going to put some of these types of questions up just to